Hi everyone, I hope everybody is doing great. And My name is Ankur Gupta. I am back with my new video in which I'll talk about blockchain. What I'll try to do in this video series is talk about technology in short capsule. And today we'll talk about blockchain. And the way we'll talk about it is, talk about some of the myths that the word blockchain uh, might bring to your mind. Some of the underlying assumptions that you might have made by reading a few information online or whatever. uh, and then we'll talk about what's the underlying technology, and obviously what is it based upon, so that you can understand and appreciate what this technology is and what it does, and what is the benefit that users get from it. And finally we'll talk about some of the applications of blockchain. So let's get started. So firstly, what is blockchain, right? It's not Bitcoin, or it's not a cryptocurrency like few of the people might just say it is, right? Bitcoin is a cryptocurrency which is based on the blockchain platform. So now these are two different things. These are not the same thing. And whenever somebody talks about blockchain, it is not necessary that you are referring to Bitcoin. So please, that's the first myth that I wanted to bust. And the second thing is, blockchain applications are limited to financial services. I think that's another myth. Blockchain has users in financial services, which we look at. However, there are multiple other uses of blockchain, and we'll talk about all of those in the applications of blockchain when we touch upon that topic. Right now, please, in your mind, I think you should not think that blockchain is only limited to financial services. No, there are plenty of other use cases for blockchain. Blockchain is proprietary. Again, a few of the people might say that blockchain is a proprietary technology. No, blockchain is an open source technology, and there could be customizations that one can make in order to solve for specific use cases or specific applications. However, blockchain as a technology is open source, and it's available for everybody to work upon, and to create their own kind of blockchain environment. Um Now let's talk about what's the underlying technology. How was it? How did it came in being? And how it came in being is quite interesting. It was based upon research which was founded by Satoshi Nakamoto, and the identity of this person is quite anonymous. And there have been multiple debates as to who is Satoshi Nakamoto. However, what we should be really interested in is, like, what is the principle behind this technology. And the principle is very simple. There are ledgers which are distributed across the entire internet, or entire peers, and it is not reliant on one specific server or one centralized location. The data is actually distributed across, and that actually is a very big and a unique feature of blockchain. It is a highly distributed ledger, and it ensures the authenticity of the data. That of course is one aspect of the authenticity. There is of course a cryptographic technique which actually lends authenticity to the data, and that is called hashing. So basically, every block in the blockchain contains data, and every data in the blockchain has a hash code, has a unique code. And what exactly is hashing? Hashing is a way of basically protecting your data to ensure that the data authenticity, it is not changed. The data is verifiable using that hash code, and the hash code is unique again to your data. So if I say my data could be my name, and even if I and with the hashing that I do on my name, the hash code that I get will be unique. And even if one letter is changed in my name, or there's some spelling something else, so maybe the last name is written first or the first name is written at the end, the hash will change, the hash code will change, and that basically ensures that for me that it's my data if the hash code is matching. And essentially every block contains data associated with the unique hash code, and this hashing is I think the key and the main element of blockchain, which actually gives it authenticity, where users can ensure that that the data that they are seeing is authentic, and if anything, I think this is the biggest feature of blockchain, and the fact that it is distributed and available to everybody to verify the data, and there is no really requirement of an intermediary in the transaction to establish the trust. It ensures that the data format is one, that whenever the data is updated in one system, it's available in all the systems that the data needs to be in and interacting with. And I think that lends a lot of credibility to blockchain, and this hashing is one key ingredient of it. The next thing about I think important about blockchain is, like every ledger, the key in every ledger, from a financial standpoint, is that nobody can go back in time and edit or modify the data that that they think is wrong, and or with the wrong intention actually erase, let's say, a transaction detail or a transaction history, or they can modify the value of the transaction. That is ensured by blockchain actually being an append only system. And basically what I mean by append only is, like, if there is any changes in the data, it can only be appended. It cannot be, actually the previous record cannot be edited, right? And that lends a lot of power to blockchain, because now users can rest assured that the data that they are looking at any point is authentic and is validated. And that is what the ledger actually solidifies the fact that it's a ledger. It has all the history of transactions that that are possibly there since the inception of that entire exchange. And at whatever point you can see what is the way and who edited the data, what was the value exchange, what is the current state of data. Everything is possible to to be seen out there. So I think that is one powerful underlying technology that blockchain is. With that, let's actually look at what blockchain does. What blockchain does is enable users to exchange data, verify the data authenticity, and exchange value. So with this three, I think to take an example of let's say a real estate purchase. Whenever a real estate purchase happens in the US, there's an escrow account set up, and then the buyer and the sellers kind of interact, and then the seller actually says that okay, I want X million dollars, or I want this amount. The buyer actually sets up an escrow account first, and of course pays an escrow commission. First transfers the fund in that escrow, and once the buyer has actually transferred the amount to the seller, then the seller actually gives the documents and the handover process to the buyer. So there's a lot of back and forth. If you see in this process, there's a lot of there are intermediaries here, like the escrow account, and then probably a set of lawyers from each of the parties, and of course they'll have their own ways of storing information of let's say bringing in, if you bring in insurance, if you bring in other parties to the play. I think there will be a lot of parties together, and that is what blockchain actually does. It enables seamless transactions in this kind of a multi-party system. If everybody was on blockchain, sharing the same amount of sharing the similar platform for exchanges of data and making transactions, every party in the system involved will have access to what is going on, what is the latest amount transferred. There will be a record of the transfer by whom to whom, and who's the beneficiary. There could be also smart contracts. Smart contracts is an interesting concept of blockchain. uh, they're not contracts per se, but there are instructions actually embedded in the code in blockchain, stored like data, which can actually follow certain rules and follow basis some data exchanges or basis some transaction exchanges. It can be triggered to follow certain rules. For example, if party A has actually done the transfer of X million or whatever amount to party B can actually give the ownership rights, or the asset gets transferred in the name of party A. And this could be all done in a smart contract, where the smart contract actually determines, okay, the funds have been actually transferred, and now the asset can be actually transferred into party's A name, or the buyer's name. So it establishes a trust in the system, and it takes away all the requirement of a lot of email exchanges, a lot of reconciliations, a lot of intermediaries in the system. And it actually helps all multi-party systems actually talk to each other using one platform, come on one platform, and exchange information on the same data platform. So I think that is the power of blockchain. And there are significant applications of this technology, which we'll talk about in the next slide. Okay, so now let's look at some of the applications of blockchain. And any multi-party environment where data or value is exchanged, blockchain can actually act as a single source of truth that every party sees, and it is updated on a real-time basis. It's a ledger so that everybody can view it. It is not dependent on a centralized system. It is distributed across the network. It is distributed across the peers. So if one user has updated information or made a transaction, it will be available to the rest of the network in no time, because from one peer to the other peer to the other peer to the other peer, it will be actually distributed across the network, and everybody in the network will have a copy of the data and have the copy of the transaction, which will actually enable users to verify and authenticate the transaction. And it has immense applications across the industries, across I would say across areas of financial services, financial transactions, supply chain, or digital identity. And when we actually look at a couple of examples, it will be more clear. So let's talk about healthcare. Now, in healthcare, there are a lot of parties involved. Of course, there's the person who is actually taking the treatment, patient. There are doctors. Doctors are looking at the health records of the patients, and there are hospitals, big hospitals, who are actually doing medical reporting, or they are performing tests on the patient. And then there are insurance companies. So if you see here, there are a lot of parties involved. And if you look at from a patient perspective, if the patient is going from one doctor to the other, suppose you go to a general physician, you get yourself diagnosed. The general physicians will recommend a specialist of a specialist doctor. So you go to the specialist doctors, you again have to tell the entire story. You have to talk about your medical history and everything. Think of blockchain. If blockchain was there, probably all of the doctors could have a view of your health information, and you can control as to what information you want to share, or how much information you want to share, and for how much time. And I think that is one real powerful use of blockchain. And it enables you, it saves you time, going to multiple doctors, avoiding avoiding repeating yourself, avoiding probably a lot of visits where one doctor sees the information, and every other doctor that you want that information to be seen can see that information potentially and diagnose you in less time. And sometimes in life threatening situations this becomes key because it saves time, and it can actually have a lot of impact when it comes to healthcare. Thinking of talking about doctors, same thing is applicable when you do reports, when hospitals actually do test, and you're going from one lab to another lab. All of that information is your health information. It's stored in blockchain, and you can actually open access to whenever you want your reports to be shared with the hospital or to the insurance companies to verify the bill, hospital bill, etc. It has immense applications. And the time consumed for insurance company to actually verify the records by looking at the data can actually be cut. The insurance companies can already have a view of what is going on, what is the treatment, how many doctors have been consulted, which what's the diagnosis. Everything is available on blockchain, and it can save a lot of reconciliations, a lot of back and forth on emails, a lot of data exchanges which are usually done in some form or the other. It can eliminate a lot of paper based reporting and all of that, and enable hospitals, doctors, patients, insurance companies a seamless transaction every time a patient is actually cured. So those were the applications in healthcare. A similar application, an interesting one, could be in general an insurance company. For example, every customer having an insurance could potentially be aligned on different insurance companies, right? And different insurance companies might have their own systems. The person, of course, might have insurance company X. Another person might have an insurance company Y. Think of car insurance, for example, and suppose person X and Y smash their cars together, and they will invoke. The process is actually long. They'll have to notify their respective insurance companies through an email. Now then the first incident of report will be verified. There will be, of course, investigation from the police. So each insurance company will ask for that investigation copy from the police independently. There will be back and forth between insurance companies, the police, between the customer, and of course it will add a lot of time in the process, and a lot of like I said, back and forth, a lot of data requirement, a lot of reconciliation requirement of the data, and all of this time can be eliminated if, let's say, every party in this case was on blockchain. Let's say all the insurance companies actually are able to talk to each other using a common platform, and also talk to, let's say, the police department using that platform. And that's where blockchain can be that platform and can be customized to have a permissioned kind of blockchain where only a specific users get access, and the level of access is also controlled. So if you see now, blockchain has a lot of potential and a lot of applications. Let's talk about another example in travel. Whenever you travel international, you carry your passport as your identity proof, and of course you need to actually cross borders. You need to actually have your passport stamped at the border control. Now look at it this way. Suppose everything was on blockchain. Your personal information with your name, your personal address, your country, your age, everything can be actually stored digitally on blockchain, and forming your digital identity. And this digital identity is with your is in your control. It's only accessible by others with your permission, and for you can control who actually sees that information and for how long. So that's really powerful. And if you're traveling to a certain country, you can open up your digital identity, and you can, share your travel plans, and the border control can actually have a view of, view of your digital identity, and they can know before you really come, that you are coming, and they know, what's your history, where you're from, and they know all those details, your purpose of visit. And when you actually reach the border, they have that information with them before you arrive. And that's really powerful, and that saves a lot of time. Again, probably they'll just detect your face, and they'll allow you to go ahead. And that's actually happening between a host of countries. For example, I think between Canada and Netherlands, it's now, they use blockchain to actually have a pre check on, who's coming, and what's the purpose, etc., to make sure that the process is smooth for the travelers. And imagine, this can start right from when you book the tickets. So so we talked about applications in healthcare, we talked about applications in insurance, we talked about applications in travel. There are applications in supply chain, because there are immense applications in supply chain, because in supply chain there are so many parties involved, from the manufacturer to the end consumer. There's so many parties involved. How the product moves at every stage can be tracked using blockchain. And so that the the end consumer actually knows what is it, where is the raw material sourced from, and how is the actual supply chain moving in this product. And everything is on a click of, let's say, a scan of the barcode in that product. So that information is actually quite useful for users, and the users actually appreciate that information, because then they know, whether there is like, um, respectable environment friendly sourcing, or a different kind of sourcing. So that is the power of blockchain. I hope you like this small talk about blockchain. And please leave a comment if you like this video, and we can discuss more in your comments. Thank you so much. Please be safe, and keep reading and keep motivated.